In today's lecture, we are going to prepare for exam 4. Let's get started. For each scenario listed below, determine whether the scenario represents an independent or dependent sample. Recall, independent samples are samples that are unrelated, and matched paired samples are samples that are related. Part A, comparing pre-test scores before training to post-test scores. These are going to be the same individuals. Since these are the same individuals, they are related and therefore matched pairs. Part B, comparing the number of speeding tickets received by men to the number received by women. These are totally different individuals, separate groups. They have no relationship with each other, so this is independent samples. Part C, comparing pain levels of a group receiving a placebo to a group receiving a medicine. These two groups are different groups, so they must be independent samples. They have no relationship to one another. Part D, comparing pain levels before and after treatment with magnetic therapy. These are the same individuals. We're comparing the person before the treatment and the person after the treatment, so these are matched pairs. Question 2. Do shoppers at the mall spend more money on average the day after Thanksgiving compared to the day after Christmas? The 45 randomly surveyed shoppers on the day after Thanksgiving spent an average of $133. Their standard deviation was $48. The 57 randomly surveyed shoppers on the day after Christmas spent an average of $128. Their standard deviation was $49. What can be concluded at the alpha equals 0.10 level of significance? First thing I need to figure out is what kind of test this is. Notice there are two samples in the problem. We have 45 randomly surveyed shoppers after Thanksgiving and 57 randomly surveyed shoppers after Christmas. So there's two different groups. And it is referring to the average money spent. So this must be a two sample mean test. But is it independent or is it dependent? The biggest giveaway is the difference in sample size. We have 45 versus 57. So these two groups are different groups. They have no relationship with each other. So these two groups are independent of one another. We can start with the claim. What is the claim? The claim is, do shoppers spend more on average after Thanksgiving than after Christmas? Let's let group 1 be the Thanksgiving group and group 2 be the Christmas group. So we're claiming mu1 is greater than mu2, and the complement to this is the opposite. Mu1 is less than or equal to mu2. Now we can state our null hypothesis. Our null hypothesis is mu1 is less than or equal to mu2. We always have the null hypothesis with the equal sign. The null hypothesis always has the equal sign. It is also acceptable to put mu1 equals mu2. That's also acceptable. For the alternative hypothesis, HA, we have mu1 is greater than mu2. That's step 1. In step 2, we'll state alpha. The level of significance is given as 0.10. Before we do step 3 and 4, we need to go back to our problem and figure out some information. The sample size for group 1 is 45. The sample mean for group 1 is 133. And for group 1, the standard deviation is 48. Now for group 2, we have the sample size is 57. The average is 128. And the standard deviation is 49. So we need these numbers to enter it into our calculator. The calculator that I will be using is the two independent samples with statistics calculator. Let's enter the sample size for the first group. That's 45. The sample mean. The sample mean is $133. The standard deviation is $48. And for group 2, the sample size is 57. The sample mean, $128, and the standard deviation is $49. We'll have to select the inequality. We're going to use greater than because that's the alternative hypothesis. You always select HA for this symbol and click calculate. We have our test statistic, our t statistic, and we have our p-value. So now we can enter these into our problem. In step 3, we have the test statistic t is equal to 0.518. And in step 4, our p-value is equal to 0.3030. In step 5, let's finish our conclusion. We ask, is the p-value less than alpha? Our alpha was 0.10, and our p-value is 0.3030. Our p-value is not less than alpha. We do not reject the null hypothesis. There is not enough evidence to conclude, and our conclusion is always in terms of HA. HA states that the mean of the first group is greater than the mean of the second group. We do not reject the null hypothesis. There is not enough evidence to conclude that the average spent after Thanksgiving is greater than after Christmas. Since the p-value is not less than alpha, we do not reject the null hypothesis. There is not enough evidence to conclude that the average spent after Thanksgiving is greater than after Christmas. Question 3. Do college students enjoy playing sports more than watching sports? A researcher randomly selected 10 college students and asked them to rate playing sports and watching sports on a scale from 1 to 10. With 1 meaning they have no interest and 10 meaning they absolutely love it. The results of the study are shown below. Assume a normal distribution. What can be concluded at alpha equals 0.05 level of significance? This must be a 2-sample mean test that is dependent. Now I know this is a 2-sample test because we have 2 groups, group 1 and group 2. This also must be dependent because we're talking about the same 10 individuals. We asked them 2 different questions, and so this is a dependent test. We will start the problem by stating the claim. The claim is, do college students enjoy playing sports more than watching sports? Group 1 is playing sports and group 2 is watching sports. So the claim is mu1 is greater than mu2. And for the complement, it's the opposite. That's mu1 is less than or equal to mu2. Step 1 is to state the null hypothesis and the alternative hypothesis. The one with the equal sign is the complement, so that's HO. Mu1 is less than or equal to mu2. HA is mu1 is greater than mu2. Step 2 will state alpha. Alpha is equal to 0.05. In step 3 and 4, we're going to have to use our calculator for this problem. The calculator that I will need is the one that is for 2 dependent samples with data calculator. So let's enter the values. For our alternative hypothesis, we'll click the greater than symbol and select calculate. Here is our test statistic. T equals 1.964 and our p-value is equal to 0.0406. In step 3, we'll write our test statistic. Recall our test statistic is t is approximately 1.964, and for our p-value we are going to round it to 4 decimal places, 0.0406. In step 5, we'll state our conclusion. I always ask, is the p-value less than alpha? The p-value is less than alpha, so we do reject the null hypothesis. There is enough evidence to conclude, and again, our conclusion is always in terms of HA. So we're going to say that the mean of the first group is greater than the mean of the second group. To conclude, on average, college students enjoy playing sports greater than watching sports. Since the p-value is less than alpha, we do reject the null hypothesis. There is enough evidence to conclude, on average, college students enjoy playing sports greater than watching sports. Question 4. Are freshman psychology majors just as likely to change their major before they graduate compared to freshman business majors? 316 of the 608 freshman psychology majors from a recent study changed their major before they graduated, and 349 of the 742 freshman business majors changed their major before they graduated. What can be concluded at the alpha equals 0.10 level of significance? The first step is to figure out what kind of test this is. Notice we have 316 out of 608 and 349 out of 742. There are 2 samples involved, and this is a fraction. This is a fraction or proportion. So this is a 2-sample proportion test. Let's start with the claim. The claim is, are freshman psychology majors just as likely to change their major before they graduate compared to freshman business majors? So the claim is P1 is equal to P2. Just as likely means equal. The complement would be the opposite. The opposite of this would be P1 is not equal to P2. This is in fact a two-tailed test. But since I'm going to be using the computer, we don't need to double the p-value. This is just going to be done by the computer for us. Step 1, we'll state the null and alternative hypothesis. The null hypothesis is P1 equals P2. It's always the one with the equal symbol. HA is P1 not equals P2. In step 2, we'll state alpha. Alpha is equal to 0.10. In step 3 and 4, we'll have to go to our statistics calculator for this question. The calculator that we'll be using is the 2 proportions calculator. For group 1, the sample size is 608, and the number of successes is 316. For the second group, the sample size is 742, and the number of successes is 349. For the alternative hypothesis, we have not equals. Let's click calculate. And here is our test statistic. Our z statistic is 1.806 and our p-value is 0.0709. Since this is a 2-sample proportion test, we have the z statistic is equal to 1.806 and our p-value is equal to 0.0710. In step 5, we'll state our conclusion. Is the p-value less than alpha? The p-value is 0.0710. It is less than alpha, which is 0.10. So we do reject the null hypothesis. We do reject the null hypothesis. There is enough evidence to conclude, and again our conclusion is always in terms of HA, to conclude the proportion of psychology majors that change majors before graduation is different than business majors. Since the p-value is less than alpha, we do reject the null hypothesis. There is enough evidence to conclude that the proportion of psychology majors that change majors before graduation is different than business majors. Question 5. Are phone calls equally likely to occur any day of the week? The day of the week for each of the 546 randomly selected phone calls was observed. The results are displayed in the table below. Use alpha equals 0.01 level of significance. In part A, we're going to complete the rest of the table. The first step is to find the expected frequency. The expected frequency is equal to the sample size times the probability. And since we're assuming that each day of the week is equally likely, that's going to give us a probability of 1/7 because it's 7 days in a week. The sample size is given to be 546, so we have 546 times 1/7, and this should give us a value of 78. Since each of the days of the week is equally likely, all of these should be 78. Now there's only one hypothesis test that has frequencies in there, and that's the goodness of fit test. This is a goodness of fit test. So let's get started. We will start with step 1, the null hypothesis. For the goodness of fit test, the null hypothesis should be stated as a sentence. It's a little bit easier to state it as a sentence. We are going to say the distribution of phone calls is uniform, which essentially means there's no preference in the phone calls and the days of the week. For the alternative hypothesis, it's the complement of the null hypothesis. The distribution of phone calls is not uniform. Is not uniform. In step 2, we'll state alpha. Alpha is equivalent to 0.01 level of significance. In step 3 and 4, we'll have to go to our statistics calculator for that question. We'll go to the goodness of fit calculator and enter the observed counts and the expected counts. Then click calculate. Here is our chi-squared statistic, and here is our p-value. So we'll write our chi-squared statistic. That's equivalent to 12.205, and our p-value is equal to 0.0575. We can also state our degrees of freedom, which is equivalent to the number of groups minus 1. Since we have 7 days of the week, we'll subtract 1 from it. The degrees of freedom is 6. Now let's write our conclusion. Is the p-value less than alpha? Is 0.05 less than 0.01? No, it's not. So we do not reject the null hypothesis. There is not enough evidence to conclude. And our conclusion is in terms of HA. We'll just copy HA. HA says the distribution of phone calls is not uniform. The distribution of phone calls is not uniform. Question 6. A fitness trainer is interested in investigating whether ethnicity and the first exercise activity that members engage in are dependent. The table below shows the results of the trainer's observations of randomly selected members. Now, if you look at this table, a lot of students might think the phrase frequencies is mentioned. So this must be a goodness of fit test. That would be incorrect. If you look carefully, the phrase dependent appears, so this is a chi-square test for independence. This is a chi-square test for independence. I know this because we're looking for the relationship between ethnicity and exercise activity. So this is a chi-square test for independence. In step 1, we'll state the null and alternative hypothesis. In step 1, we want to figure out the relationship between ethnicity and first exercise activity. So for a null hypothesis, we have the following. The ethnicity and the first exercise activity are independent. Make sure you mention the phrase independent for the null hypothesis. For the alternative hypothesis, we're going to copy the null hypothesis, except replace independent with dependent. So we're going to say the ethnicity and the first exercise activity are dependent. Make sure you use the phrase dependent for the alternative hypothesis. For step 2, we'll state alpha. Alpha is equivalent to 0.01, and that's given here. In step 3 and 4, we'll go to our calculator for the chi-square test for independence. You have to enter the values into the table. The first, second, third, and fourth are the ethnicities, and A, B, and C, those are the types of activities. If we click calculate, we should get a chi-squared statistic of 17.128 and a p-value of 0.0088. So write down those numbers and we'll put those in step 3 and 4. Chi-squared is equal to 17.128. And our p-value is equal to 0.0088. Now we can start step 5. We ask, is the p-value less than alpha? You always ask, is the p-value less than alpha? And in this case, 0.0088 is less than 0.01, so the p-value is less than alpha. We do reject the null hypothesis. There is enough evidence to conclude, and remember our conclusion is always in terms of HA, so just copy HA exactly as it is. To conclude, the ethnicity and the first exercise activity are dependent. Question 7. A researcher wants to know if there is a difference between the mean amounts of sleep that people get for various types of employment status. The table below shows the data that was collected from a survey. If you look carefully, we have 3 different groups, and we're looking for the mean. So this is an ANOVA. This must be an ANOVA test because we have more than 2 groups. The ANOVA test is the only test that has more than 2 groups. The ANOVA test is a pretty convenient test because for the null hypothesis, it's always the same. It's always mu1 equals mu2 equals mu3 for how many groups we have. In this case, we have only 3 groups. And for the alternative hypothesis, we're going to say at least one group has a different mean. In step 2, just state alpha. Alpha is 0.1, and it's always given in the problem. Alpha is given here. In step 3 and 4, I have to go to our calculator. Let's go to the ANOVA calculator and enter our values from our table. I have entered the values for data 1, 2, and 3 into the ANOVA table. We have our F statistic is 8.238, And our p-value is 0.0025. In step 3, we'll state our F statistic. Our F statistic is equal to 8.238, and our p-value is equal to 0.002, and we'll round that to a 5. In step 5, let's finish our conclusion. We always ask the same question. Is the p-value less than alpha? Is 0.0025 less than alpha? Yes, it is. So we do reject the null hypothesis. There is enough evidence to conclude, and we're just going to copy HA. To conclude, at least one group has a different mean.